Good afternoon, everybody, and welcome to Agri-Food Conversations, brought to you by iSelect Fund, the Van Trump Report, the Yield Lab Institute, and Family Farms Group. My name is Tom Bunn. I'm an associate on the iSelect Fund investment team, and I'm excited to welcome you all to our discussion today. As many of you know, Agri-Food Conversations is all about driving innovation in food and ag. Each month, we highlight a specific theme, and this month's is technologies related to aquaculture. And on today's call, we are joined by Larry Feinberg, the CEO of KnipBio, which is using synthetic biology to solve some of the nutritional challenges in the global aquaculture industry. Each of you knows companies are more likely to succeed with the right network of customers, talent, investors, and advisors. We've invited you to this call because you are some of the smartest, most talented people in KnipBio's market. You are potential customers for KnipBio's products and services. You built a company similar to KnipBio, or you are a sophisticated business person or agriculture professional, or in this case, aquaculture professional, who understands their market and the challenges and opportunities that KnipBio may face. Before we get started, we have a quick poll question to get a better idea of who we have on the call today. Please take a few seconds to answer. And while the poll is going, a few process comments. We are not soliciting investment in any way whatsoever. This presentation is provide information to help KnipBio find customers, mentors, or other strategic relationships that can help them grow their business. Secondly, you are all on mute. However, you can use the chat window to ask a question at any time, and we will open it up for Q&A in a broader sense after Larry goes through his presentation, and I can unmute you to let you ask Larry a question directly. Finally, this presentation is being recorded and will be available for replay. So with that, I am pleased to introduce Larry Feinberg, the CEO of KnipBio. Take it away, Larry.
Well, I really appreciate being here today. So thanks so much, Tom. Good to be with you again, and we'll welcome the opportunity to talk more about KnipBio and aquaculture, a couple of my very favorite things to talk about. So one of the lead ups to this conversation in the write-up in the blurb ahead was some of the challenges around aquaculture, of which there have been many. This is a fast growing field and certainly has had a lot of growing pains along the way. One of them primarily has been the inputs, what we feed fish. Historically has been very reliant on marine resources, like growing fish on farms using sardines or anchovies that are ground up into fish meal and fed to fish. Alternatively, we started to use a lot of terrestrial proteins like soy. Both of these have some limitations in both supply and nutrient limitations as well. And not unrelated, but also additionally is issues around disease. As we've increased our cultivation intensity, when you crowd animals together, it just tends to make them more vulnerable in any setting, including aquaculture, which of course is just an extension of agriculture in general. And so there's been a widespread expansion of use of drugs like antibiotics to combat these diseases. And it's really just not a good situation in an aqueous environment like these, fish farms. So that's an issue. And then of course, fecal pollution and local pollution in the water, and not to mention escapes has been a very hot topic issue. Very notably is the escapes in the Pacific Northwest that's actually led to the ban of net pen aquaculture in the state of Washington. So there are a lot of issues for sure, but actually this is a very fast moving sector and really evolving and adapting just even in the last decade alone. There are a lot of things that we think we assume about this sector that have changed quite significantly over that time. So let's take a look. A lot of folks think about wild caught as an option and superior perhaps to farm raised and ideal and pristine and in its environment eating the food that it should be eating. That's possibly true. Although, a lot of our native waters are polluted with Fukushima radiation and heavy metals like mercury and of course, plastics in the ocean being an issue. So it's complicated, of course. The other major way to raise fish today, for example, is this picture here on the right, where we have salmon being grown in the pristine waters of the fjords in Norway. But the success of the industry has led to actually there's just very few new sites available in places like Norway and Chile. And so one of the ways that this industry continues to diversify and expand are these land-based systems, these recirculating aquaculture systems, where a lot of innovation and technology development is happening. It's a really exciting sector, and actually solves quite a few of the issues on the previous slide in terms of cultivation intensity issues like disease and fecal pollution and escapes. All of those are potentially solved in this type of system. But ultimately what really matters is that we have a really high quality product that customers love, and expands the overall protein basket for folks to enjoy. And so the focus really has to be on great tasting fish. So what has led to the need for aquaculture? And if you think about the global population, it took over 12,000 years to go from 4 million to 4 billion people on this planet. That's astounding, right? And actually, it's just in the last 4 decades where another 4 billion people came onto the planet. That's actually pretty close to my lifespan. And so in that time, it's not only numbers of people, it's actually another 3 billion people have risen out of poverty into the middle class, where they're more affluent today, consuming more protein in some of the most populated countries like China, India, Indonesia, which happen to be really strong seafood bearing diets. And so the demand for seafood is rising, in addition to the demand for protein is rising. And so for millennia, we were able to pull as much protein out of the oceans as we needed. But that's changed again, also in this 4-decade time frame, where we've really plateaued and we've leveled off the amount of fish that we've been able to pull out. Actually, in that time, the percentage of exhausted fisheries has gone up to almost 90% today. That all these fisheries today are basically either at capacity or overfished. And so how we made up for that protein deficit over these 4 decades is what we've gotten pretty good at, raising fish on farms. And so today it's about 1-to-1, one fish on the farm for every 1 fish wild caught. And that number should go to 2-to-1 by the end of this decade. So if you run out the math of, well, okay, we've always gotten better at how much protein we can pull out of per acre, for example, and of terrestrial proteins. And you say we're going to get better at recovering animal byproducts. And you assume that, you know what, aquaculture 7 to 11% CAGR growth annual is only going to be 5% going forward. And you check that out towards the end of this decade, 2030. There's a protein deficit as big as the entire fish meal pot that we're missing, that we need to fill in the next decade. And so how are we going to fill that? One, of course, is insects, perhaps algae. And of course, I'm going to be very biased in my perspective in that single cell proteins, these are proteins derived from bacteria, typically, that can be grown in a fermentation vessel like a brewery, essentially, with a 1,000 times smaller footprint than a soybean farm, with a strong flexibility and biotechnology tools is really going to be part of the solution. And it's exactly what we need. We need the speed that biotechnology brings to this. And what is so wonderful about aquaculture is its diversity. It's also what's such a challenge. But take a look at this picture here. There's something like 600 marketable species in aquaculture. And if you throw out some weird ones like frogs and seaweeds, you're still talking about hundreds of fish and shellfish. And how dramatically different is a carnivore like a salmon to a crustacean like a shrimp that wears its shell on the back, right? Only having the kingdom Animalia in common, right? So there's some really important differences versus other livestock industries like cow, where it's one species, maybe multiple different breeds like Jersey and Holstein, but it's really ultimately one species, and it's had 12,000 years to develop versus aquaculture. It's something like 50 years in development. So we certainly, looking at those previous slides of where the world is going in terms of protein demand, We don't have that same luxury going forward. And so the idea that we can create strains on a weekly basis and deploy them, not wait till next season to see what happened, but wait till next week to find out how they are in terms of their fermentation characteristics, etc. It's incredibly powerful. It's the right tool for the right sector in the right time. And so that's exactly what KnipBio is doing. We have a whole series of protein products based on our microbial platform, really with a focus towards aquaculture's health and nutrition, but logically will expand to other animal livestock sectors pretty seamlessly. So we actually have our first product is launching as we speak with a whole slew of products right behind it. And I'm going to talk a little bit more about those in the coming slides. But all in all, this is a very big sector, very strong need, and each of these products have potentially very high value. So going into these land-based systems, these recirculating aquaculture systems is really where the action is right now. It's almost every single day there's a new headline about this sector where hundreds of millions of dollars are being poured in to each of these facilities. And this is a picture on the top right that I took a picture of Atlantic Sapphire down outside of Florida, outside of Miami in Florida, of course. And this was almost 2 years ago when they were first building their nursery and their hatchery, which was 9 acres under roof. The entire facility will be on an 80-acre footprint. And when they're done, they say they'll produce about 10% of the US's salmon consumption equivalent. And the thing is, there's about 4 projects in Maine and about another dozen projects across the country announced and in development, and at least another dozen projects around the world. So there's a lot of activity here. And what's driving this revolution is, especially now in a post-pandemic COVID-19 era, having opportunity to deal with supply chain disruptions, having proximity to markets has never been more important than now. But ultimately, the potential to have a higher quality product that's made locally effectively with zero to very minimal environmental footprint is very appealing and is more and more what the customers are demanding. But there is definitely some key issues here. In fact, because something like between 95 and 99% of the water is recycled, the accumulation of these off flavors in the form of MIB and geosmin accumulate in these waters and actually deposit into the fillet of the animals. And if it's not dealt with, it tastes horrible. It can really be very muddy and earthy. And so today, the major way that it's dealt with is essentially to purge fresh water through the fish. And that's a whole bunch of inefficiencies in terms of the overall weight of the animal. They lose biomass. You have the potential for a lower quality because if one fish isn't purged enough, it could have other effects. But also you're slowed down your ability to harvest. And so there's overall delays in the process. So it's actually one of the most significant issues. And when we did all of our customer discovery issues, this definitely came up over and over again as, if not the number one, very close to it issues in this sector. And as a farmer told us directly, it just takes one bad tasting fish to ruin our relationships with our customers and affecting their ability to sell their product. So it's really important that we figure something out. And actually, KnipBio has one of our proteins is able to dramatically, significantly reduce these off flavor compounds in the fillet of these fish without purging. It's really unique and special and different in this way. But the real proof is how does the fish taste? And on the far right, we did a simple cooked as simply as possible with blind taste panels and found statistically significant non-detection of these off flavors in these panels, and then went to the other end of the extreme and had top tier sushi chefs, a Boston sushi chain restaurant chain called JP Fuji, which I highly recommend. They are absolute masters. If you're ever back in the Boston area or in Boston, go there. But anyway, yeah, so even and all these circumstances, it was detected to be very, very clean and pure and delicious. So having a nutritional solution that's not mechanical, but actually can help promote greater growth of the fish, healthier fish, also happen to be a fish meal alternative, helps to improve the existing infrastructure, makes the overall process more efficient, while improving quality, is exactly what the industry needs. Well, really what we have, again, is a platform. And so we've produced our products, several products above pilot scale, and we're commercially manufacturing today 3 different products. And this is what our product looks like. It's essentially a pink flower. And that's a little bit of a secret. The word nip is the word pink backwards. Not really a secret, but now you know. And so really what we can do is use the existing hardware where we use liquid feedstocks and existing off-the-shelf fermentation equipment, not anything particularly special in terms of the engineering, to drive products towards juvenile feeds, towards other animals like shrimp, and then ultimately towards grow-out feeds for adult salmon and trout and other types of finfish. So we really have a portfolio of products that will be sequentially released in time for different applications, again, using the same platform. So beyond the off flavors, the next product coming down the pike here is actually improving health. And so here's an example where we did a shrimp trial in Thailand, where there actually was a cold snap, and you could see the control and the experimental diets that we were working with our partner with. They saw a survival in the 60%, where the KnipBio diet actually saw something like an 80+% survival. So sometimes these environmental stresses can be really impactful, but also what typically happens is once there's an environmental stress, then a disease, a parasite like Vibrio parahemolyticus, which is one of the most deadly shrimp diseases in the world, will really just decimate an entire crop within just a couple of days. And you'll see in this example here, where you see in the same shrimp were then taken out, intentionally delivered to this Vibrio parasite, where you see something like a 70% mortality in shrimp in the control diet versus only below a 30% mortality in the KnipBio diet. So getting shrimp in the basket and onto the market is basically the difference between profitability and going out of business. But another effect that we've seen also with juveniles, in this case juvenile shrimp, is more of the nitrogen in the form of protein, less in the form of fecal matter, higher conversions, and this ultimately will transfer to a juvenile vigor towards an adult type of benefit going down the stream. So really thinking about the entire life stages of the animal and having our different protein products being able to address multiple different issues. And that's the advantage that biotechnology potentially offers. So the feedstocks that we use typically are liquid, but another differentiating feature for us is the diversity of feedstocks. We can use C1 compounds that essentially can help sequester carbon, but also we can use agricultural waste streams, for example. This was an effort that we did in concert with ICM, an engineering firm that designed and built and constructed about 110 of the 200 corn ethanol plants. And the idea is to potentially co-locate next to one of these facilities where there's an existing waste stream for us, helps diversify the overall productivity of that site. And we can leverage the synergies in the site in terms of infrastructure, utilities, wastewater treatment, and lots of other advantages. So it's a real benefit and has the opportunity to expand the agricultural profitability, especially in this case in the Midwest USA. So today we are manufacturing at scale. We've done quite a bit of work over the last 7 years, where we've done about 40 animal trials to date. And we're the first of our kind to receive an FDA approval here in the US for this type of product. So we're turning the corner out of development and R&D and into commercialization. And of course, this is a technology that's built with multiple hands contributing, with multiple different skill sets in terms of biotechnology and animal nutrition. And ultimately, we have a really strong team that's gotten us to where we are today. So in summary, tomorrow is not going to look like today in any way, shape, or form. And we have to do more with less. We have to do more in a smaller footprint from the inputs and inputs that don't directly compete with humans for feeding the human supply chain. And without a doubt, industrial biotechnology and aquaculture are going to solve many of these big challenges. And so ultimately, we need to develop aquaculture. It's been proposed that something like 2% of the ocean is enough volume to supply the entire planet for protein. And if you think about it, aquaculture works in 3 dimensions. It's not just 2 dimensions like crops, right? Because you can obviously go up and down and out. And so the ability to produce so much more with so much less, no doubt this is going to be a contribution towards a food secure future. So I really thank the opportunity to speak to the iSelect audience today, and appreciate your time, and hope that I can answer some of your questions. So if there's some additional information, here's how you can get in contact with us. Thanks so much.
Thank you very much, Larry. Great presentation, and thanks for the sushi recommendation for Boston. I'm gonna remember that one. To everyone in attendance, as a reminder, you can raise your hand and I can unmute you, or feel free to type a question into the Q&A box, and I will go ahead and read it out loud to Larry. Looks like we have one from Ed Rogers that's already come in. Ed asks, is your product an all-in-one feed, or do you need to mix in other ingredients such as supplements in order to have a complete feed solution? For example, inositol often is used as a supplement in shrimp feed and other aquaculture feed.
Right. Sorry. There was a second part to that question. This is an ingredient. Our FDA approval is for up to 10%. So, in fact, that is how the industry works, that no ingredient should be greater than a certain percentage, that there should always be a diversity. That's called a practical diet. So yeah, we'll be an ingredient. We see ourselves a bit like the Intel Inside, and the ability to provide not just a source of protein, but these functional molecules within the overall protein it's essentially a delivery of these functional molecules.
Great. Looks like we have another one that came through from Kent Johnson. Kent asks, what channels do you target? Do you try to sell wholesale or to end customers?
Well, it really needs both push and pull in our case. So our direct customer would be the major feed companies that are going to take our product and essentially formulate a compound feed. But our end user are the fish farms. And so, it's really a conversation between both the farmer as well as the feed company to design and put together the best, most nutritious, most sustainable feed possible.
Got it. I will say there's a follow-up. Is getting approvals in Europe more challenging than getting approvals in the US with the FDA?
Well, first, the FDA approval was definitely a challenge. From the beginning to end was something like a 5-year process, from introduction to actual approval. But with the EU, when it comes to genetic modification, yeah, that is a huge red flag. So we have diversity of products that would not be considered GM for the European markets. And actually, when you have a non-GM product, it's quite easy. In fact, it's far more of a simple process than the US process. So the long-winded answer is it depends. But yeah, if it's a GMO product, it is maybe unfair, but it's a really tough process for sure.
Great. Peter Hawthorne asks, versus conventional salmon feed formulations, what are you usually replacing?
Well, I think that's part of the beauty of this product is that it's flexible, whether you want to pull out terrestrial proteins or you want to put out marine proteins or animal byproducts, it's fungible, it's drop-in. And what we found is that it really depends on the farmer and what their goals are. If you're trying to get into the whole foods market, for example, you can't use animal byproducts, which is actually a fantastic, like chicken byproducts is a fantastic alternative to fish meal. So if you're trying to get rid of fish meal and you're trying to get into whole foods, that doesn't leave you a whole lot of options. So it just really depends on what the goals are of the farmer in terms of what we're going to replace and change.
Got it. I guess as a follow-up to that, what can you replace? Is this from a protein and an amino acid point of view? Is this a direct replacement for, let's say, soy protein concentrate?
It's better than soy protein concentrate. It's roughly equivalent to fish meal on an amino acid basis, but for it does not have omega-3s. Nature sort of gives you an either or option.
Yeah.
And this is not a great source for lipids.
Got it. Meg Brigman asks, what is your estimated commercialization timeline?
Yeah, for this first product, we're ready to go. In fact, even for the second product as well. And so we expect to make some announcements within the next couple of months in terms of commercialization, offtake, and manufacturing. So we're in that transition phase where we're starting to grow up as a company quite a bit.
Fantastic. Peter Hawthorne has a follow-up. He asks, what portion of total manufactured cost, does your feedstock represent?
Well, at this in-between phase, feedstock is not nearly comparable to the actual rental cost of a total manufacturing facility. That's the biggest cost. But typically, our feedstock will be something like 50% or so of our production costs.
An anonymous attendee asks, can you discuss the company's IP portfolio and strategy?
Well, there's a combination strategy. We have quite a bit of IP that's published and is searchable around our organism, and some of the additional functional molecules that we're able to weave into our protein. But this is a global sector, and so actually there's quite a bit of our IP strategy that is trade secret and not necessarily that we've gone protected. So what you might see on Google patent search is maybe not all that we have in terms of our IP.
Terrific. Any other questions from the audience? While they are deliberating, Larry, I guess a good question for you would be, so you have your contact information here. What help do you need? How would you like our audience, as you know, we broadcast this and distribute this to a fairly large group of people. How best can our audience help you?
Well, I appreciate that, Tom, and I appreciate the opportunity to be able to tap into the network. So, we are preparing for a pretty significant growth phase, and that means a lot of different things all at once, which means scaling up in manufacturing, in identifying assets, as well as producing within those assets, as well as everything related to the operation. Right? So that's sort of one bucket, and then of course financing and other financial strategies related to that growth strategy. So that would be a couple of very quick responses there.
Terrific. Looks like an anonymous attendee had a follow-up while we have you here, Larry. They ask, are you able to procure a composition of matter patent on the organism?
I'm not totally sure of the nature of that question. I wonder if we can follow up on that. While that's being written, I mean, the organism itself is non-patentable. I mean, that is, a naturally occurring organism. But the ability to do things with that organism, to manipulate it and to apply it is certainly protectable and has been protected. So I don't know if we could clarify the question a little bit, or if that answered the question.
Great. Well, I'll let the anonymous attendee reach out to you directly if they have any follow-up questions. But Larry, thanks so much for joining us. Congratulations on all your progress. It sounds like 2020 notwithstanding, you've had a stellar year. So kudos to you. I'd also like to thank the audience for their active participation. And as you know, we host these calls every week, every Thursday at 3 p.m. Central. Again, this month's theme is aquaculture related. So we'll be touching on feed as we just have, and also some other technologies in the growing and important space that is aquaculture. So you can register conversations by going to agrifoodconversations.com. And if you know someone that would like to watch this webinar, who's dipping their toes into the aquaculture space, feel free to share it with them, because again, a replay of this webinar will be emailed to you in the next 24 hours, and they can register on agrifoodconversations.com to replay that themselves. So thank you all for joining. Larry, thanks so much for joining us, and hope to talk to you all soon.
Thank you.